Hey, Wire Monkeys, welcome to another episode of Let's Talk Cabling. This episode, we're talking about anti-static flooring. Welcome to. Welcome to the show where we tackle a tough question submitted by installers, estimators, project foremen, project managers, customers. We are connecting at the human level so that we can connect the world. If you're watching this show on YouTube and you like this content, would you please hit the subscribe button and the bell button to be notified when new content is being produced? If you're listening to us on one of the audio podcast platforms, would you mind leaving us a 5-star rating? Those 3 simple little steps helps us take on the algorithm so we can educate, encourage, and enrich the lives of people in the ICT industry. Wednesday nights, 6 p.m. Eastern Standard Time. What are you doing? I do a live stream on TikTok, Facebook, LinkedIn, YouTube, and anywhere else I can where you get to ask your favorite RCDD, and you know that's me, your favorite RCDD, your questions on installation, design, certification, project management, estimation. I even do career path questions. But I can hear you now. But Chuck, I'm driving my truck on Wednesday nights at 6 p.m. I can't watch a video. I'll crash my truck. I'll go. Relax. I record them, and you can watch them at your convenience when it is safe to do so. And finally, while this show is free and will always remain free, if you would like to, and you find value in this content and you would like to help support the show, would you click on that QR code right there? You can buy me a cup of coffee. You can even schedule a 15-minute one-on-one call with me after hours, of course. And we're also looking for sponsorship as well. So as I said in the intro, anti-static flooring. What the heck is that? Is it required? What does it do? You know, in the TDMM, the Telecommunications Distribution Methods Manual, it tells us that the TRs should, you remember what should means, should have anti-static flooring. But that's all the information it really gives you. It doesn't go into depth. And I didn't really think about it until a few weeks back. I was doing a tour at the Bixie Learning Academy, and Christopher Hobbs mentioned they had anti-static flooring. I remembered, oh yeah, that's in the TDMM. But it doesn't go into depth with it. So you know me, I got on the old Google machine and I typed in anti-static flooring to find out what in the heck. What is it? How's it installed? What are the options? What the heck is this thing made out of? How does it dissipate anti-static electricity? And I happened to come across this company and this individual. This individual, that I'm going to do in just a second, he trains people on how anti-static flooring works. Welcome to the show, Dave Long. How you doing, my friend?
I am doing great, Chuck, and I really found a lot of inspiration in your introduction. You have a lot of energy and you have a lot of passion for what you do, and it's contagious.
I've got accused of that before. I did a sales meeting with a company one time, and they were taking me around and introducing me to people, and uh, and the guy says, "Oh, this is Chuck Bowser. He has a podcast." And the guy he introduced me goes, "Oh, what's your podcast about?" He was thinking it's gonna be something like cool, like camping or survival or gardening. I said, "No, I do it on cabling." And he goes, "Oh, well, when I get off work at 5, I don't even want to think about cabling, dude. My mind is always thinking about cabling, always, always. I'm trying, you not being in the industry. The whole reason I started the podcast was I noticed this thing called the gray tsunami, where a lot of people are aging out of our industry, but we're not really attracting a lot of younger people to our industry. And we as an industry are horrible about training our newer people because we want to keep that information close to our vest. I'm close to retirement. All the information that's in here, I give it away to anybody who wants it. I'm trying to inspire that next generation. So that's where all that passion comes from. The passion is not necessarily cabling. The passion is I'm trying to inspire younger people that this is a viable option for a career path. That's for those who didn't know that because I've gotten a lot of new subscribers lately. So why don't you go and tell us who you are and the name and your company and what are you guys famous for?
Well, I got involved in the static electricity problem solving world in 1976, so it's been a while. Um, and the company that I operate, that I started, is called Staticworx. And it's kind of interesting. You talked about giving away information, taking what's here and passing it on to the next generation. Because when we started our company, we had to think about not just who we want to be, but how we want to be what we are. And we made what we thought at the time was a risky decision, which was let's just give information away. I'm sure everybody that's listening has had to deal with that. If you want the article, you have to provide your email. And the next thing you know, for the rest of your life, you're getting one email per day because you made that mistake. Well, we kind of we don't like that. I think most people don't. So we just decided let's give it away and see what happens. And the best thing about it, and this is an old, I guess, rhetorical statement, the best customer is an educated customer.
Ding, 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 ding. 10,000 points right there. Say that again, please.
The best customer client is an educated one.
Thank you.
You're welcome.
Thank you. I get in that argument with people all the time because, our industry is very codes and standards driven, and customers don't know anything about cabling. So they hire us to do it. And then when we want to do it the way the codes and standards say to do it, they'll tell us, I don't have the money for that. Then I always tell people, well, that we got to do it because that's the way the customer wants it. No, it's your job to educate the customer so they can make the wisest decision for the budget and the problem they're trying to solve. You have to educate them.
Yeah, exactly.
So glad to hear you say that. Oh my gosh. So great minds think alike. What can I say?
I didn't come to that conclusion on my own. My head of marketing came to that conclusion and said, I think you should do this. I went along with her opinion, and the rest is history. So when we reach out to the world, we're actually not really talking about products. We're talking about the problem, the options, the risk of not doing it versus doing it, and what the various solutions might look like. So, you brought up something kind of interesting, the word should. Should and shall become a big deal in standards organizations.
Yes.
So, right? And people argue about, because I belong to some standards organizations, and they actually argue about, do we use should here or shall? Because shall is a pretty strong term if you follow the letter of the document. Now, when you're audited, if you don't have what you were supposed to have, you can be dinged in an audit. If it's an electronic manufacturing facility where they're building semiconductors, that can mean losing a customer. In the world where I think cabling kind of fits in, which is server rooms, comm centers, dispatch areas, data centers, there's no document that says you have to do something. There's a lot of shoulds. So I get calls from architects and designers, and sometimes they'll tell me that they were going to put carpet in, and the person that they were dealing with, who they specified carpet, told them they don't really need it. And I'll say, well, let's start with the fact, do they know anything about static electricity? And the answer is no. And I say, do they have anti-static carpet? And the answer is no. And so, those two answers you just gave me might explain why one of the reasons is they said you don't need it. But let's actually talk about it from the bigger picture, which is risk reward. If I'm doing what I'm doing right now and I have a static event, you're gonna ding me back, and we're gonna get back in line and talk to each other. But if I'm running a electrical power plant and my system goes down, or I'll give you even a better example. If I'm in a flight tower, years ago I got called by an airport. I won't get into the exact specifics because it might make people a little nervous, but they called me because I was local and they were losing track of aircraft. When I got to the flight tower, first thing I noticed was that, that new carpet smell?
Yeah.
Okay. I noticed the new carpet smell, and very quickly they told me, yesterday we put this carpet in. And they were carpet squares, for anybody that doesn't know what a carpet tile is. So these carpet squares. And the problem that we encountered was they told a local flooring contractor, we want the same thing we already have. The carpet was blue, it was square. So what did the local flooring contractor give them? Blue squares. However, no one remembered that probably 15 years earlier, those blue squares were purchased to have static dissipative properties, anti-static properties. We can get into what that is in a little bit if you want. But they put in regular carpet, and there was enough static electricity being generated that it was affecting their systems. So that's an FAA application. And just so you know, the FAA says shall. They don't say should.
So So let's take a side step real quick because there might be some new people listening to this show who don't really thoroughly understand the impact of should and shall, right? So for us, there's three main types of books that we pay attention to: codes, standards, and best practices. Should and shall is in all three of those. If the word shall, for those who don't know, shall is a requirement. You have to do it. You don't have a choice in the matter. If you don't, people can get hurt. People probably can get damaged. You might even be held legally liable for the damage, especially if it's in the code, right? When you get to the standards, you will find the word shall there too, but standards are voluntary. So technically, we don't have to follow the standards if we don't want to. Now, the better companies do follow the standards because standards guarantee performance. Now, if you enter a contract with a customer that says your work will meet and or exceed the ANSI standards, now all those shalls in the standards become absolute requirements, right? So should is a recommendation. So that's why I tell people all the time, words have meanings. Be careful which words you use, right? And that doesn't surprise me at all when you said they fight over that whole should and shall, because I've sat in a few committee meetings myself, and you're exactly right, because they have such a huge impact legally. People can be actually put in jail if it says, you shall put in a fire stop system that matches the rating of the wall, and if you don't, and people get injured, you can actually be put in prison for that because it was a shall and it was in the code. So should and shall, very, very important words.
Hey there, business owners and tech enthusiasts. Are you tired of dealing with outdated technology and unreliable IT support? Introducing Better Days Technology, Rhode Island's premier IT solution provider. Whether you need secure network setups, top-notch cybersecurity, or seamless software integrations, Better Days Technology has got you covered. Don't let tech troubles hold you back. Visit betterdaystechnology.com or call 401-440-5483 today. One call to us and you'll be having better days. Now, let's get back to the podcast.
And then you also mentioned, you're talking about, I didn't know they made anti-static carpet. I just learned something new today. ESD, electrostatic discharge. It wreaks havoc on computers, wreaks havoc on hubs, routers, servers. And so it's really, really, we don't want static at all, right? So why don't you go ahead and tell us what are some key benefits for anti-static flooring, specifically talking about tiles, because we don't put carpet in our telecom rooms, right? And what kind of environments, in the environments where you're going to find low voltage cabling?
So believe it or not, a lot of ESD carpet does get into telecom rooms. A lot.
It's not supposed to, though. That's where the best practice comes in. The best practice says, carpet, no, should not be putting carpet in.
So this is always of interest to me because years ago, one of my customers was Cisco, and Cisco had a huge footprint of buildings in Northern California in the San Jose area, and they used our ESD carpet in all their burn-in areas. They had acres of it, and the reason they used it is, first of all, it got rid of static electricity, but it also was a great sound attenuator. So just picture a 40, 50, 60,000 square foot building with a bunch of, call them servers, call them telecom systems, but all with intake cooling fans, all operating at the same time. You'd want to walk around there like you're at a heavy metal concert with a set of earplugs. So for them, it was the ideal solution. And I want to just make it clear that there are numerous modes of material that you can use to eliminate static. There's epoxy, there's carpet, anything you can walk on. We can figure out a way to render it into what's loosely called an anti-static floor. But in the dispatch and comm world, ESD carpet is actually a really popular choice, not because of it just being carpet, but because of ergonomics to do with sound. And I'll get it out early on. It's not our biggest product, so we're not here to tell you everything gets solved by one solution. But you gotta think about problems from the perspective of the people in the space too. So that becomes a challenge for us because people will say, I want it to be anti-slip. I want it to be low maintenance. I want it to get rid of static. I want it to meet standards. I want it to be inexpensive. You know how these laundry lists get put together.
Right. Well, I really want to focus on the tiles because, like I said, the TDMM, the Telecommunications Distribution Methods Manual, recommends not to use carpeting. And again, recommends, not requires. Another key difference there. And I have seen telecom rooms with carpeting in before. My concern with carpeting is the technician or the engineer may not, or the customer may not realize if that carpet's static or not. And if you don't put in, anti-static carpeting, again, huge. We've all gotten. We used to do this as kids, right? We'd walk around and shuffle our feet, and we'd go touch your brother, your sister, and zzz, right? Well, again, that wreaks havoc. That shows up as common mode issues, differential mode issues, computers rebooting, losing data because of that electrostatic. And those are just the minor problems. The major problems is you can burn out something on a chipset on the motherboard. Yeah, the motherboard. There you go. I almost said mothership. Where's my brain at today? So that's why they really want you to try to use tiles. So I'd like to focus today's conversation, even though there is electrostatic discharge carpeting out there, because the recommendation is for tiles, I'd kind of like to stay focused more towards tile than carpet per se. Like I said, I didn't know that till you said something. Now, can you explain what makes a product anti-static? How does it dissipate that electric? And what kind of materials are they using to get that goal?
Okay, so let's talk about tile squares like you would buy at Home Depot, right? So we call that vinyl composition tile. VCT is the common term for it. Regular VCT is a static generator. And by the way, what makes something a static generator is that it can't move electricity. So for example, Chuck, if I said to you, take this piece of tile, take your outlet apart, take this piece of VCT and go over and touch your electrical outlet, you probably wouldn't be too afraid to do that because you're not afraid to plug your cell phone charger in, right? The reason you're not afraid to do that is because you know the plastic housing on your cell phone charger isn't going to conduct electricity and shock you.
Right.
What if I asked you to stick a paper clip in the electrical outlet?
No, it's conductive.
Exactly. So we need to make things conductive in order to conduct electricity. That means we have to take VCT and put something else in it to get it to discharge static electricity. We can use carbon, we could use metal, we could use silver and gold, but they're kind of expensive. Most what we call ESD, electrostatic discharge tiles, what we do is we use carbon. We put these little filaments inside the tile, and then we install those tiles with an adhesive that also has carbon in it. So picture a room that's empty, and we want to put a floor in there that'll get rid of static electricity. We also want to ground it. So what we'll do is we'll spread a special adhesive on that floor that has carbon in it. And then if we were to test that floor with an ohm meter to look for continuity, even before we put the tiles on top of it, we'll have continuity because what we've essentially done is installed a sticky ground plane. Now when we put tiles on top of it, one next to the other, next to the other, next to the other, we're building a matrix of materials on top that are all, I guess you could say, electrically connected to the same ground plane. And then we ground the adhesive with a copper strip, usually to an electrical outlet. We can use building steel, but it's usually the AC ground that's most commonly used. So now we've built a surface that'll accept static charges. But that's not the end of it. Because one of the things we have to think about is, if I have a charge on my body and I walk on that floor, can I charge up based on the shoes or footwear that I have on? And that's where it gets tricky because, for example, back to that flight tower, I would not be able to tell flight control personnel, you can't wear your shoes anymore. You got to wear this special footwear, right? I have to come up with a solution that I can ground, that I can test with an ohm meter to prove that it's grounded. But I also want that floor to be very forgiving and allow me to walk on it without accumulating a charge. So when we look at floors and we talk to our customers, we're asking them really two questions. And those questions are, what kind of footwear are you wearing? And what's the sensitivity or risk associated with your business? So to go back to the should and shall for a minute, even if you take those two words off the table, if it's a control room at a nuclear power plant, what's your risk if your system goes down? Pretty high, right? I mean, and believe it or not, the big risk in gambling resorts. We do a lot of work with people in that industry. So people will say to me, do I need to use anti-static flooring? I don't know enough about their equipment because they don't know enough about it to tell them, oh yeah, you have a such and such piece of equipment that's sensitive to this voltage. My question is always, how much can you afford to have downtime or to have all those problems you just talked about?
Right.
And that's an easy question for most people to answer.
That's a great point because, we do a lot of cabling in casinos because those one-armed bandits have basically mini computers inside of them. So we run cabling to them. And I know this because they're real sensitive to EMI. But like you said, the risk, right? What's the risk if one machine goes down? Okay, there's not a big impact there, right? Well, to the casino there is because they're not making money off of one out of 5,000 one-armed bandits. But in the low voltage world, the risk is huge because you could lose your phone service, you can lose your network, you could lose your video surveillance system, which is monitoring. Think of banks; they got video monitoring systems to monitor the vaults and stuff. Think about prisons; they're monitoring the prisoners. There's a huge risk to static and ESD.
There was a study done by ASHRAE. Are you familiar with ASHRAE at all?
No.
So I always forget exactly what these letters stand for, but it's ASHRAE, and it's the Association of Heating, Ventilating, Air Conditioning, and almost sounds like it'd be like a consumer group,
right.
But they weigh in heavily on the design of data centers because data centers obviously generate a tremendous amount of heat, and because they generate a tremendous amount of heat, they need air conditioning. And what ends up happening in data centers, because they're so dry, because of the heat generated by computer systems, they need to be air conditioned. So they've done a number of studies on how could we reduce the requirement for elevated humidity and still control static electricity. Because I think everybody knows you don't get as many shocks when you touch a doorknob in Florida as you do in Denver in January.
Right, exactly.
And what's the variable? It's the humidity, right?
Right.
So in data centers, if they could reduce the humidity, believe it or not, they can lower the cost of operating the data center because now they're not trying to cool humid air. But anyway, the long and short of it is they determined that ESD flooring is a tremendous attribute, and the people in the study that were involved in the study were from all over the world. They were actual scientists, and one of their statements was, you have to buy a floor anyway. You have to put a floor in anyway. Right. So in this environment, why wouldn't the floor have static control properties? That was basically their sort of takeaway.
Yeah. So for purposes for my industry, low voltage contractors are not going to be installing flooring or anti-static flooring, right? They're if that gets put in their ballot, if they get put in their scope of work, they're going to hire a flooring contractor to do that, and then they should specify, hey, you need to put in anti-static flooring. That's why I'm having this conversation with you, because most engineers in our industry couldn't tell you. I didn't know that they used carbon it was in the glue. So you got carbon in the glue, and then you got some kind of a copper element sitting on top of that and tiles on top of that.
The only place where we use copper is actually connecting the ground plane. So let's say the room's 50 by 50. That 50 by 50 room, in a few locations, we would press part of a 24-inch long piece of copper onto some spot on the adhesive, just at the edge of the room, up to the electrical outlet. The carbon impregnated adhesive Think of it as carbon. Think of it as copper itself. As long as the floor has electrical properties, which I described by either adding graphite or carbon to the floor, and it touches that adhesive, you've got an electrical path from the top of the floor through the tile to the adhesive, across the adhesive to the copper to ground.
Gotcha.
And we use carbon because it's cheap or cheaper.
So let me ask you this question: what's the expected lifespan of anti-static flooring versus a traditional floor in like a commercial setting?
So in terms of lifespan, as long as it's not a heavy industrial environment, you're actually looking at no difference. The fact that the floor has conductive properties doesn't impact its durability. Now, I will tell you, there are technologies for ESD tile that don't have the properties built into the floor. You have to use special polishes on top of them, and we usually end up in a discussion at some point with most people looking at a solution. How do you know when it's time to replace those polishes? Who's going to test them? Because the properties are invisible. I mean, if I showed you one tile that was an ESD tile and one that wasn't, and I chose them carefully, you wouldn't be able to tell the difference. The only way to know is to put an ohm meter on the floor and measure electrical continuity.
Just a regular ohm meter, like the one I got in my tool bag right now?
So you need a special probe for it.
Okay.
So the one you have in your toolbox has little points.
Right.
Okay. The one we use to test the floor, the probes have to be 2.5 inches in diameter, and they have to be 5 pounds in weight.
A surface area contact.
Exactly.
Gotcha.
Surface area contact. And that means you're probably going to want a kind of beefy ohm meter, because your typical volt ohm meter is probably going to crash because of the load of those two probes, because it just doesn't have the output. Gotcha. So those probes, by the way, have been around since the 1950s. They're called NFPA probes. We've been testing floors the same way for 70 years.
Hold that thought. Let's listen to a short message from our sponsor. Don't go anywhere. Bessemer Industries is your trusted partner in cutting-edge telecommunications and security solutions in Central California. From structured cabling and fiber optics to comprehensive telecom and surveillance systems, we've got you covered. Enhance your business with seamless connectivity and top-notch security. Our licensed and insured team ensures that you get the best service tailored to your needs. Why choose Bessemer Industries? Expertly crafted solutions, reliable and secure installations, licensed and insured professionals. Don't wait. Connect with us today and elevate your business to new heights. Bessemer Industries, connecting and securing Central California's businesses one wire at a time. Visit us at www.bessemerindustries.com or call 559-314-7050. Bessemer Industries, your link to seamless connectivity. Now, let's get back to the show.
So let's talk about the installation process, right? So this is really geared for maybe the project manager who's looking over the project. They're doing regular inspections on a project. They're out checking on the crew in the field somewhere. They see the tile guys putting in the anti-static flooring in the telecom room, right? Or maybe I do have a lot of people who listen to my show who have their small low voltage companies where they might only be just them or 5 or less people. And this might be something that they might want to do because they did this before somewhere else, did tile or carpeting or whatever, right? Let's talk about the installation process. You mentioned already that there's glue. So I'm imagining the glue would you lay it out the same way you would glue with a regular anti-static floor, correct?
Same process. So if you've ever watched somebody install tile in a bathroom, or maybe at a grocery store where they're doing a repair, you'll see a tool they call a trowel, right? It's got little teeth. You drip some adhesive on the floor and you spread it with the trowel. You let it dry for a certain amount of time. In some cases, like we have a glue that you let dry completely until it's sticky, and then you put your tiles on top of it. So it's the process of installation Any flooring contractor that knows how to use a T-square and a chalk line and knows how to cut a tile, for them, the process is no different than installing regular tile. And there are even free-floating interlocking tiles now.
I was going to ask you, was gluing the only option?
No, the industry's changing. Because of labor costs and floor preparation and repairing concrete, there's actually a very big interest these days in free-floating floors. And if you can picture like a dovetail sort of an arrangement, almost like kind of like floors you see in a gym, those black rubber floors.
Yes.
Yes. These big gyms, except something pretty that would look like you could be around it all day long, and it looks clean. But there's a lot of different ways to install these floors. They do all need to be grounded though, and that means that at some point along the perimeter of the room, you need that copper strip.
Well, I mean, that's a perfect lead into my next question, right? Couple questions, for as far as bonding that floor to a ground. You already mentioned the one method of tying it to the electric receptacle. I only know this because I watched your video, or maybe one of your competitors' videos. I don't know. I watched like several videos. It's a copper thing, maybe 2 inches wide, I guess, or so, and it literally comes up the wall, and then you put a tiny little hole in it, and then you run the screw that holds the receptacle to the box through that copper base, and then somebody recommended using metal plates as well. That's one way of bonding it to the ground, right?
That is
another method, and I saw this at the Big C Learning Academy in Tampa. They came up, and then they did a split bolt to a bonding conductor to a bus bar. Now our industry is huge on installing bus bars because we got to run conductors from that bus bar to the rack to bond that rack to a ground. And then usually that bus bar is either tied to structural steel or maybe its own independent ground that's been installed, driven in per the NEC, meets 25 ohms resistance or less, all that fun, good stuff to go. Let's talk a little bit about, is there any other methods besides those two?
We just finished a job. It happened to be for a manufacturing facility where we use the I-beams in the building.
Okay.
So they sanded the paint off the I-beams, and then they attached the copper to the I-beam. They drilled and tapped, used a screw and a washer. And the reason they did that, by the way, is the I-beams did not have electrical outlets on them, and the building was 250,000 square feet in size. So it was pretty far. We want to have a ground approximately every 1,000 square feet. So
that actually brings a great question. So for every 1,000 square feet, so most telecom rooms are going to be 10 by 11. So that sounds to me like, there are bigger ones, don't get me wrong, but most telecom rooms are small. So that sounds to me like it's just going to be one attachment point to a ground.
Right. And I usually advocate two, and I'll tell you why. It's not because you need them. It's because some point in the life of that room, someone may visit that room and wonder what that is and why it's there.
Yeah.
We all know about that.
2 is 1, 1 is none.
Exactly.
Dad always used to say that. Always have a backup, son. Always have something, because something will happen. It just will. That's very cool. So let's talk about the maintenance of these things. So this is going to be geared towards maybe like the service tech who's going out, to a customer, a couple times a year doing work or whatever. What kind of maintenance is required for anti-static flooring to ensure that it's still conductive to a ground source?
So are we talking about a manned space or usually an unmanned space?
Most of the time unmanned.
Okay. So if the space is unmanned, it makes a difference because now we're not dealing with traffic affecting the floor aesthetically, right? So just to back up, because it plays into your question, when that floor gets installed, ideally after it's installed, someone, usually the supplier of the floor, arranges for the floor to be tested. So now you have a baseline. So for example, I mentioned that process where some products rely on a floor finish. A lot of times that floor finish doesn't get applied because flooring contractors a lot of times don't apply flooring finishes. Mm-hmm. So it never gets put in. So you want the floor to be tested when it's new. If the floor has permanent properties and it's never, because we're talking tile, it never gets waxed, those properties aren't going to go anywhere. So if it's unmanned and it's a permanent product, that even while it's still in the box, has these conductive properties, I'm not as concerned about that person coming in to do maintenance having to look at that floor. The option's always there, but the most important thing I can tell anyone that buys an anti-static floor is write in your specification something like this. Upon completion, the manufacturer or the manufacturer's representative shall test the floor per ASTM F150 and provide the results in writing. That gets you where you need to be.
Nice. I like that. What about data centers? The whole let's talk about data centers, and that's still that maintenance thing. Is there more concern for maintenance in a data center than a telecom room?
No, not really. You know, it's funny. We're actually doing a job for a big data center group right now, and we've actually brought up maintenance a couple of times to them, and at least in this particular instance, I'm not getting the feedback that I would get from like a manufacturing operation where they would build the equipment that goes into the data center. Normally, once a data center is operational, if they move heavy systems like some of these big Dell systems and IBM systems, they're using some kind of a motorized trolley, which is pretty easy on the floor. If they're moving a system, they've got to worry about the casters damaging the floor, but that's something that doesn't have to do with time. That's something that the floor has to be specified properly to begin with to handle those weight loads. It's not about endurance over time. So if the right floor is put in to handle the weight loads to begin with, their maintenance isn't really much more than a clean room, which, as you know, doesn't have a lot of dirt in it. Otherwise, we wouldn't call it a clean room.
Right. Can anti-static flooring, does it have to be, can it be installed over an existing floor? Like, let's say you have, in our industry, a lot of times what happens is the telecom room is usually the last thing that's thought about, because customers, they're geared about, building out the offices and the modular furniture areas, stuff like that. And they don't even think about the telecom room till an RCDD says, hey, we need a 10 by 11 room. So they go find a broom closet or something. Let's say it may already have some existing flooring in it. Can anti-static flooring be put on top of that, or does that have to be scraped down to the concrete or whatever the base structure is for the anti-static flooring to work?
It absolutely can go over the old floor, and the way we sort of state this is we can't guarantee that the old floor's bond is perfect, right? So if the tiles are curled up because maybe they had a flood 3 years earlier, that you wouldn't cover that anyway. If the old floor is flat and in decent shape, it's actually a good decision, because if you remove that floor and there is equipment in there already, you got to shut down. You've got to get rid of the old adhesive. You might discover that that's an old room, and maybe at one time there was even asbestos tile in there, because up until the late 60s, asbestos was a very common component. So sometimes from a restoration perspective, you solve a lot of problems by going over the floor. That can be done with a free floating floor or with certain adhesives. But yeah, it's a very common tactic, and it saves money.
You mentioned just a few minutes ago one standard, and I can't remember what is off the top of my head. Our industry is driven by standards. As a matter of fact, I got a complete set of telecom standards. Actually, it's in the other room. That book's literally like this. It's 3 inches thick. It's a huge thing. So we have lots of standards, lots of best practice. I was kind of glad to hear you say that the anti-static flooring industry has that too, because that tells me that you guys are really, really looking at safety, performance, and uniform installation practices, testing practices. What kind of standards guides the anti-static flooring industry?
So there are test methods and standards. So most of the test methods for testing anti-static properties come out of a group called the ESD Association, ESDA.org, if you want to look them up. Now, I will tell you that organization, from the ground up, no pun intended, is built around designing a static control program for manufacturing electronic devices. So a lot of the things that they require and a lot of their parameters are specific to touching components with your fingers. and I just want to get this out there, most of the time, telecom systems are not as vulnerable to an ESD event as the components that are on those circuit boards. So when they're building microelectronic parts or they're building circuit boards, they need to go way beyond where your clientele, your audience would want to go. But so there's the ESD Association. They have standards and test methods. Some of them might apply to what we're talking about. ASTM, and everybody knows what ASTM is. ASTM for years and years has had a test method for testing the resistive properties of a floor using those 5-pound weights. And by the way, the history of that goes all the way back to when they used conductive floors in operating rooms to prevent explosions when people were administered ether as the anesthesia.
Oh,
so,
wow.
Yeah. And by the way, I bring that up because when you install a floor, obviously you want to conduct electricity, but for your audience, I think everyone would agree, if the power went out in your house and you had a flood in the room where your circuit breakers are, you probably wouldn't stand in water and start flipping circuit breakers, right?
No.
So we don't want floors that are too conductive. We want to have floors that conduct electricity, but conduct it at a controlled rate. ASTM has a minimum resistance requirement. And I don't know if you want to, if you're listening to this, you want to write this down, but that number is 25,000 ohms. And that's kind of a sacred number in my industry because it was calculated all the way back into the 1950s when the NFPA and Underwriter Laboratories and all these organizations had to think about what floor might be too conductive to use in a room that has a defibrillator.
Oh, wow. I didn't even think about that. Yeah, exactly.
So we want something that gets rid of electricity. So we don't want plastic on the floor, right? But at the same time, we don't want the floor itself to be made out of copper. Copper's okay to connect the floor, but we want the floor to have some amount of resistance in it. So that's the 25,000 is the sacred number.
Here's a funny story for you. I don't tell this very often. I used to be a firefighter EMT many years ago. And I ran a call in PG County, Maryland. I ran a call at Byrd Stadium. Well, I don't even know if it's called Byrd anymore. It's the football stadium for University of Maryland, right? Somebody was having a heart attack. Now at the time, I was just an EMTA. I wasn't a paramedic. So we get there and the paramedic showed up. And most football stadiums, they got the metal bleachers, right, that you sit on. And it was raining because it was typical November weather in December. This lady was having a heart attack, and the paramedic used the defib on the patient on the metal bench while it was wet, and shocked everybody on that bench. Everybody on that bench. So in the low voltage world, when we drive a ground rod, right, the code tells us we have to be 25 ohms or less. So for us, the magic number is the closer to zero, the better. Explain to me that 25,000 is a lower number better, is a higher number better? What's the theory behind that 25,000 ohm?
Okay, so let's just to put it all together. That 25 ohms connection to ground, that's the guarantee that what you're actually going to is a good connection to earth. Okay, that doesn't have anything to do with the floor. The floor, if I build a floor with a certain amount of electrical resistance, what I'm doing is I'm controlling. I mean, think of it this way: I'm controlling the decay of electricity through that floor. And the best example I can give you is there's a lab that I work with, and this is not a required test. It should be, but unfortunately it isn't. Anytime we look at new products or new product designs, one of the things we do is we have this lab connect the flooring material to a voltage source and then ground the floor, but we measure the current, the electrical current that the floor can support. And for the most part, this is always the case, but for the most part, the amount of resistance that's in the floor is a good predictor of what that electrical current will look like. The reason I say most of the time it's a good predictor is a lot of these anti-static flooring materials are multi-layered, and depending upon how, when voltage meets the floor, if it finds one of the more conductive layers in the floor, or call it a hot spot, all bets are off. So that's one of the reasons we do this testing, because we know that voltage doesn't kill, current kills.
Mm-hmm.
And there's all sorts of charts you can go online and see where they'll tell you how much electrical current, you say, ouch, how much you can't move your arms, how much you can't move anything ever again. So we try to think about that. So when we look at floors, we don't want to just be at 25,000. We probably want to be no less than 100,000, because you never design anything right next to the point of failure. You want to have a buffer.
Yeah.
And if you're building a bridge that had to hold 1,000 pounds, you wouldn't build it to hold 1,001. You'd probably want it to hold 5,000 pounds.
Yeah, you're going to want at least like a 2.5 safety factor or something.
Exactly. So when we look at floors, we have this thing we kind of call the sweet spot. I actually made a graph because I used to play golf, and you always know when you hit a ball perfectly, you hit the sweet spot, and maybe you play tennis. Anyway, the sweet spot in my mind is a buffer in between what we call the limits at both ends. So the limit at the upper end, by the way, this is kind of important. I told you the lower end is 25,000 ohms. The upper end is 1 billion ohms. And those of you who like to think in exponents,
you got to do like this: 1 billion ohms.
Yes. A lot of ohms, right? So it's 10 to the 9th place, a lot of zeros. All right. So you don't want to be up there either, because now you're approaching a static generator. So we kind of tell people no more than 100 million, no less than 100,000 is your sweet spot. And that amount of resistance, I'm not saying it's safe, because there's a lot of foolish things people do with electricity.
Yep.
But you're stacking the deck more in your favor. You know, you mentioned liability a couple minutes ago. I wrote an article years ago, and I actually reached out to a well-known liability attorney. He writes for In Compliance magazine. I thought, seems like a good resource. And what he told me about this kind of stuff is meeting standards isn't always enough.
Mm-hmm.
If there's emerging technology or information that suggests exceeding standards, you probably want to think about doing that. It's a lot easier to defend. And, you know, in a litigious world where we're making recommendations, representations, you try to take that into consideration.
Love that. So if somebody wants to learn more about your product or anti-static flooring, how can they get in touch with you or your company?
So the easiest way, we have a website, obviously. We have a contact list, but Staticworx is spelled kind of unusual. It's WORX, like X-ray. So my name's Dave. Dave at Staticworx is one way. Info at Staticworx. If you find us online at staticworx.com, any one of our staff will be able to answer the kinds of questions I just answered for you, Chuck.
Dave, thank you for coming on the show and clearing up the air about anti-static flooring. I certainly appreciate your time.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.